example 7g, the equation is 4 times e to the x plus 1 is equal to 5. This is exponential. There's no logarithm present. The variable is x and it's located in the power, okay? So what we know so far is basically to equate the bases, okay? Well, there is base e on the left side because that's what's being raised to the power, not 4. The e is what's being raised to the power. And then the base on the right side is 5. There's no way you can rewrite 5 to have a base of e, okay? So we saw something like this earlier, okay? We're going to have to apply the properties of logarithms here because we cannot make 5 a power of e, okay? So this is very similar, and I can scroll up here. This is very similar to what we did in part F, okay? What we did was we took the natural log of both sides because the e was involved. We know ln and e will cancel, so that's why we did that, and we're going to do the same thing here, okay? This one's a little more complex because let me write down the left side here. If you go and you take the natural log, okay, because you want to, because there's an e involved, the problem is ln and e are not going to cancel because they're not side by side. This 4 is in the middle, okay? So before you can take the natural log of both sides, you're going to have to get rid of the 4, okay? So let's start solving here. Let me write the equation, okay? The first thing we're going to do is get rid of the 4, okay? E to the x plus 1, that's what we're trying to isolate. It is multiplied by 4, so we're going to start by dividing off the 4. Okay, so then the 4's on the left will cancel and give us that e to the x plus 1 is equal to 5/4. Okay, now we can take the logarithm. Okay, we can take the natural log of both sides, and it's okay to do so because if you do it, the natural log will be side by side with the e. Okay, all right, so we're going to go ahead and take the natural log of both sides. Okay, whatever you do to one side, you have to do to the other. Remember, when you take a logarithm, it has to go on the left side, can't go on the right side. Okay, so we're going to get the natural log of e raised to the x plus 1 power is equal to the natural log of the quantity 5/4. Okay, all right, now on the left side, the natural log in e will cancel. The exponent is going to come down. Okay, so x plus 1 will be left on the left side. That's going to equal the natural log of 5/4. Okay, natural log of 5/4 is going to be some crazy decimal. Just leave it as the natural log of 5/4. Okay, we are left with a linear equation. The highest power of x is 1. Okay, so we just need to isolate the x. So to get x by itself on the left side, we need to subtract 1 from both sides. Okay, so we're going to get the exact answer here that x is the natural log of 5/4, that quantity, minus 1. Okay, so here is your exact answer. Okay, so I'll write that here. This is the exact answer. This is one of those irrational, crazy answers, the directions we're talking about. Okay, so we need to go and get a decimal approximation as well per the direction. All right, so I'm going to call up my calculator. Okay, I'm going to type in natural log. Don't use log. That's going to give you the wrong decimal approximation. Natural log of 5/4. Close the parentheses because we're done with the logarithm. This is the quantity you're taking the logarithm of. We're going to subtract 1. Okay, and then here's our decimal approximation. Okay, we need to round to 3 places after the decimal point, so we'll say this is negative 0.777. Okay, hey, that's a pretty lucky number. All right, so x is approximately negative 0.777. Okay, so this is going to be our decimal approximation. All right. Moving on, okay, let's go to example H. Okay, example H, clearly this is a logarithmic equation. You see a logarithm in it, plain as day, okay? So we're trying to find the value or values of x that make this a true statement. Log base 5 of x squared plus x plus 4 is equal to 2. Okay, what you need to do for a logarithmic equation. So far, the method we know, okay, use either the properties of logarithms that we've learned or use the arrow method. Okay, arrow method's going to work well here. If you take the base of 5 and raise it to the second power, okay, that's going to give you the quantity x squared plus x plus 4. Okay, doing the arrow method gets rid of the logarithm. Okay, so look at what we're left with. Okay, we have 25, that's 5 squared, is equal to x squared plus x plus 4. Okay, this is a quadratic equation. The highest power of x is 2. Okay, so we need to either factor or use the quadratic formula. Okay, before we can do either, we need to make sure one side is 0. So I'm going to move the 25 over. Okay, so we're going to get 0 is equal to x squared plus x. 4 minus 25 is negative 21. Okay, so we need to either factor this or use the quadratic formula. I have a feeling that this is not going to factor. Okay, so I'm going to pop this into the quadratic formula. Okay, so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so here a is 1, that's the number in front of x squared. B is 1 as well, that's the number in front of x. C is negative 21. All right, so we pop these numbers in. We're going to get negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 21 all over 2 times 1. Okay. All right, let's simplify. We're going to get negative 1 plus or minus. Under the radical, we're going to have 1 minus a minus becomes plus. 4 times 21 is 84. All of this is over 2. Okay, and then let's just clean this up a little bit more. Okay, negative 1 plus or minus the square root of 85 over 2. Okay, you get two solutions for x. Okay, these are the exact values. Okay, again, this looks like a crazy answer. Okay, you know, you're supposed to go back and check your answer. Okay, because this is a logarithmic equation. I'm not going to expect you to check something this crazy. Okay, if you get a crazy answer like this, you can guarantee yourself it's going to work. Okay, I'm not going to expect you to check that. Okay, this is the exact answer. Remember, this means we're going to get two different solutions. The first solution is going to be negative 1 plus the square root of 85 over 2. The other solution is going to be, you're going to get that from taking the minus sign in the middle. Okay, so negative 1 minus the square root of 85 over 2. Okay, if you want to get decimal approximations for each one of these, we can pop these into the calculator. Okay, so I'll try that. Let's do negative 1 plus the square root of 85. Okay, so get that quantity, that's the numerator, divide by 2. Okay, so we'll say about 4.11. Okay, and then we'll get the other one by taking the minus sign in the middle. So we'll do negative 1 minus the square root of 85. Divide that by 2. Okay, so we're going to get negative 5.11. Okay, so those are the decimal approximations. Okay, if you were interested in those. Okay. All right, so those were some crazy answers. You can definitely, when you're doing these exponential and logarithmic equations, you can definitely end up with some crazy answers. Okay. All right, let's try one more. Okay, in part I, our equation is 8 times 10 to the 2x minus 7 plus 1 is equal to 4. Okay, first thing you need to do, what kind of equation is this? This is exponential. There's no logarithm present, and the x is in the power. Okay, so, you know, when you look at this, what's being raised to the power? 10. Okay, 10's the base. Okay, this is a tough one. Okay, it looks really complicated. let's, our first approach with exponentials is to get the bases the same, okay? So this is the quantity. 10 is being raised to the 2x minus 7 power. This 8 is noise. This 1 is noise. Let's isolate this 10 raised to the 2x minus 7, okay, to see what the base is on the other side, okay? So let's see here. We're trying to isolate the exponential piece, okay? I am going to start by moving the 1 over, okay? So that's going to tell us 8 times 10 to the 2x minus 7 power is equal to 3. And then again, this 8 is not being raised to the 2x minus 7 power, only the 10, okay? So I'm going to get rid of the 8 by dividing it off, okay? So I'm going to get that 10 to the 2x minus 7 power is equal to 3/8, okay? So the base on the left is 10, the base on the right is 3/8. There's no way I can get those bases the same, okay? So this is exponential. We cannot get the bases the same, so we're going to have to get more creative, okay? Remember, when we had an E, we used ln because they cancel. Now we have 10. What makes 10 cancel? Log. So we're going to take the log of both sides. Okay, so the log of 10 raised to the 2x minus 7 power has to equal the log of 3/8. Whatever you do to one side, you have to do to the other. Since I take the log of one side, I have to take the log of the other side. Okay, you absolutely have to use log here, not ln. All right, in doing this, the log in the 10 will cancel and the power will come down. Okay, so the left side will be 2x minus 7. The log does not cancel on the right side. Okay, it's still going to be the log of 3/8, which is some crazy decimal. Okay, the log does something to 3/8. Okay, this is now linear. The highest power of x is 1, so we just need to isolate the x. So we're going to add 7 to both sides. We're going to get that 2x is, let's see, I'm running out of room here. Let's go up here. Okay, 2x is equal to the log of 3/8. Okay, that's the log, that's the quantity I'm taking the logarithm of. We're going to add 7 to that. And now if we want to get x by itself, since we're multiplying by 2, we're going to divide by 2. Okay, so then these guys will cancel. So to get your x value, it is the log of 3/8 plus 7 all divided by 2. Crazy, crazy answer. Okay, this is the exact answer. Okay, and we can go and get a decimal approximation. I'm putting exact decimal. That does not make sense. So let's say exact answer. I'm going to go to my calculator and type this in for a decimal approximation. Okay, you have to use log here. Okay, so we're going to get the log of 3/8, close parentheses, because that's what I'm taking the logarithm of. Then add 7. I'm going to hit enter. That's the numerator. And then I need to divide this by 2. Okay, so just hit the division key. It's going to take the previous answer, divide by 2. So the approximation for x here is 3.287. Okay. All right, so here is our decimal approximation. And that's it for this one. All right, so those were just some, logarithmic equations to get you started. You can see now you're going to have exponential equations mixed in with logarithmic equations, and you've got to be able to tell the difference in how to work them. Okay, what we're doing now is we're going to move on to the next section. We're going to learn additional properties of logarithms that will help us solve more complicated exponential equations and more complicated logarithmic equations.